Hi, I'm Paul Battaglia, and this is section 2.2, Polynomial Functions of Higher Degree. You know, there's so much to talk about in section 2.2, so I'm joined by Gabe and Brittany, who are really going to help me out here. How are you guys today?
I'm doing well. How are you?
Good. I think, Gabe, we're going to get right into it because we really need a good way of introducing the lesson, right? So I know you have a couple things you like to try.
So just a short bell ringer that I like to do with my students is have them use a graphing utility to find the graphs of y equals x squared, y equals x cubed, and maybe a few more. And then also look at maybe y equals negative x
Right.
squared, and just describe a couple things that they notice. And I hope that this sort of leads them into gaining some understanding of the leading coefficient test.
You know, I think when you put it in students' hands like that, it really empowers them to figure out what you want them to see, and really, you know, it doesn't have you direct the learning, which is great as the teacher, you know. And I think when you talk about the leading coefficient test, I think it's important. We don't necessarily want students to memorize it, not right away at least. You know, let them discover it, let them figure out why these things are happening, and at the very worst, what they're doing is they're gaining a deeper conceptual knowledge, you know, and then hopefully in the end they're avoiding common mistakes. And I know, Brittany, you see a lot of those, right?
Yes, one of the biggest ones is they forget to put it in standard form, and they'll just look at whatever is the coefficient for the
very first term.
Yeah.
Right.
So, and then also just remembering they can actually utilize that to graph a function.
Yeah, I think, you know, and then I think you tie that in with end behavior, and I think now the picture is becoming a little bit clearer for them, you know? And I think one of the things I try to do when I get students into pre-calculus is I'm trying to get them to be a little bit more, let's call it mathematically proper. You know, so they're used to using that notation where they say as x goes up, y goes up, and they're using arrows, or they're actually saying goes up, you know?
Yeah.
And I want them to start using that more proper notation. As x goes to infinity, you know, y goes to negative infinity or what have you. And I think when you put that together with the leading coefficient test, looking for that degree, you know, I think now they get a very clear picture of what's going on. But that's really not all they need to graph, right? So
No, just like we were talking about previously, you can't just plot 2 points and find the graph. You use the leading coefficient test, and then you have to find the zeros, and then you have to do your test intervals.
Right.
And to make sure that students know that a test interval, you're looking at the x-axis, you're looking at x values, not y.
Not a point, not intervals on the
Yeah.
y-axis.
Right. And I think, so now we're bringing the picture together with them, and I think the last thing we do then in this section, nice job, is we talk about the intermediate value theorem. So I have these horses here that I would use to demonstrate to my class, you know, exactly what the intermediate value theorem says, because you know, when we talk about theorems, even in pre-calculus, even though it's getting to be more advanced math, you know, they hear the word theorem, they think abstract. That leads a lot of times to, oh, I'm not going to get this, you know?
Yes.
So
It's hard and scary.
it is, right? And so I think what we want them to feel a little bit more comfortable, at least about what the theorem is saying, right? And especially the intermediate value theorem, because, you know, here's a theorem that you know tells you what it tells you, but doesn't necessarily give you a way to execute it, right? So what I'll do with the horses is I'll say, okay, so we have this horse, this baby horse, this young horse, and let's say that in its infancy it's about 8 hands high. And then we have this race horse here, now it's grown up to be, and let's say it's about 17 hands high. And I asked them, you know, what do we know? Let's just even put years on it. Let's say this horse, you know, is a 1-year-old and this is a 4-year-old, right, at this point. We know that at some point in the interim that the horse had to be, let's say, 10 hands high. You know, and so we don't know exactly when that happened, but we know that there's no way it could have gone from 8 to 17 without passing through 10, right? And so, if anything, it illustrates to them exactly what a harder theorem, you know, is saying. So we hope these tips have been helpful for you. I'm sure you'll find much success in section 2.2.